Hi guys, today we're going to be reviewing fraction concepts. We're going to be completing the notes on pages 6 and 7 in your packets. So you can go ahead now and turn to page 6 if you're not already there. Our first topic today is finding equivalent fractions using a picture. So just go ahead and zoom into that first example like I have. And we can see we have a circle with half shaded in. And in the second circle, the circle's been divided into fourths. If we want to represent the same amount that is shaded here showing a half, we can see that it takes 2 of the fourths to make that same amount. And if we go to the third circle that's been divided into eighths, the equivalent fraction for 1/2 is 4/8. In our next example, we have a rectangle that's been divided into 6 equal squares. And in the rectangle next to it, same size rectangle, but each of those squares has been divided in half with a vertical line, like they did that to each of the squares. So in this example, when it's divided into twelfths, it takes 8 of those twelfths to equal the 4/6. And in the last one, they've taken out the horizontal line from our original example, and we can see that just 2/3 is equivalent to 4/6. So equivalent fractions are fractions that are equal. They represent the same amount of the whole. The second example in our notes today is multiplying and dividing to find equivalent fractions. So this first example is going to use multiplication because we're going from fifths to 20ths. So to go from 3/5 to an equivalent fraction in 20ths, I can see that I would multiply my fifths to get to 20ths, and I'm multiplying by 4. Because I multiplied my denominator by 4, I'm going to do the same to my numerator. And you'll notice if you look at that fraction that I'm multiplying by, that 4/4 right up there, that's the same as multiplying by 1. If I multiply a number by 1, I get the same value. So in fractions, it's going to look like different numbers in my numerator and denominator, but because I'm multiplying by 1, it'll be equal. So 5 times 4 gave me 20, 3 times 4 will give me 12. So 12/20ths is equivalent to 3/5. Here's another multiplication example. So to get from 4/5 to 80 somethings, I'm going to this time look at my numerator because that's where I have both numbers. So to get from 4 to 80, I would need to multiply by 20. If I multiply the numerator by 20, I want an equivalent fraction. So I'm going to multiply my denominator by 20 as well. That way again, I'm multiplying this time by 20/20ths, and that will give me an equivalent fraction. So multiplying denominator by the same number will give me an equal fraction. So 80/100ths is equal to 4/5. Now in both of these examples, I multiplied by a common factor, or the same number on the top and bottom, to get my new fraction. I can also divide by the same number on the top and bottom to get an equal fraction. 3/5 and 4/5, those don't have any common factors that I could divide by and get a fraction. But if I had something, I'm going to add this little example here. Let's say I had 4/12ths. Well, I could divide those each by 2, or I could divide them each by 4 to get a new and equivalent fraction. So if I use division here, I would get 2/6. If I use division of fourths down here, I would get 1/3. And those are 2 equivalent fractions to my original fraction of 4/12ths. Our next example, example 3, is writing fractions in simplest form. The first method they want to show us is using the GCF. And it can really be any common factor as long as you keep dividing, but we'll go for the GCF this time. So the GCF for 20 and 48. So remember, GCF would be the biggest number that divides evenly into both a 20 and a 48. And I know that the GCF for those two numbers is 4. That's the biggest number that will divide evenly into both. So to show this method, I'm going to divide both of these parts of the fraction, both the numerator and denominator, by 4 to rename the fraction. So 20 divided by 4 gives me 5 for my numerator, and 48 divided by 4 gives me 12 for my denominator. And when I look at that number, I can see that I can't divide a 5 and a 12 by any other common factor. So I know that is simplest form. Prime factorization is another method, and I went ahead already and did the prime factorizations here. So what I'm going to do is write those prime factorizations on these lines. So for 20, I have 2 times 2 times 5. Remember to write these least to greatest so you don't have your numbers all jumbled up. And for 48, I have 4 2's and then 1 3. Now what you want to do is cross off any factors that they have in common. So there's a 2 in the top and bottom. I'm going to cross those off. There's another 2 in the top and bottom, or numerator and denominator. We're going to cross those off. And our simplest term fraction is found by multiplying what's left. So there's nothing to multiply on the top. I just have a 5. On the bottom, I have a 2, and a 3. So I do 2 times 2 is 4. 4 times 3 is 12. And that's another way to do simplest form. You'll notice both of these came to be 5/12. All right, you can turn to page 7, and we'll finish our notes. So our next section, section 4, writing improper fractions as mixed numbers. An improper fraction, I'm going to highlight that term. Improper fraction is a fraction where the numerator is greater than the denominator. So let's make a couple examples of improper fractions. We could use maybe 12 over 11. So 12 is bigger than 11. That makes this an improper fraction. It can be a lot bigger, like 100 over 3, or just a little bit bigger, like 12 over 11. And then our next term, proper fraction, and I'm going to highlight that as well, but in a different color. So a proper fraction is when the numerator is smaller than the denominator. So an example of a proper fraction would be 6/7, or 2/3, or 3/100 if I flip that one over. So a proper fraction is when our numerator is smaller than the denominator. Improper, meaning not proper, is when the numerator is greater than the denominator. So here we want to write each improper fraction as a mixed number, and we have 3 steps to follow. So step 1 is to use long division to divide the numerator by the denominator. So go ahead and make that bigger so that you have room to do your dividing. We're going to do 210 divided by 4. So 4 goes in, doesn't go into the 2. Can't get a 4 and 2, so I'm going to bring down the 1. 4 goes into 21 5 times. 4 does not go into 1, so we can bring down the 10. 4 goes into 10 twice. 2 times 4 is 8. 2, 4 doesn't go into 2. There's not a number to bring down. So I have 2 left in my dividend, and my divisor was 4. So 52 2/4. So step 1, I get 52 2/4. Step 2 was the writing the remainder as a fraction, so I've done that. Now step 3 is to simplify the remainder as needed. Ooh, and I can see that my remainder could be simplified. So I am going to divide both my numerator and denominator by 2 to get my final answer. Whole number isn't going to change. I still have 52. But 2 divided by 2 is 1, and 4 divided by 2 is 2. So my final answer is 52.5. All right, let's continue with our next example. And again, we're going to follow those 3 steps. So first step is long division. So I'm going to write my top dog in the doghouse here, 176 divided by 12. 12 goes in, doesn't go into the 1. Bring down the 7. 12 goes into 17 one time. 1 times 12 is 12. I have a 5 there. 12 doesn't go into 5. I can bring down the 6. And 12 goes into 56 4 times. 4 times 12 is 48. So we're going to borrow. So my remainder is 8/12. I'm going to do my simplifying here. I can see that I can divide both the 8 and 12 by 4. My whole number will not change, but 8 divided by 4 gives me 2, and 12 divided by 4 gives me 3. So my final answer is 14 2/3 is the proper fraction or mixed number for 176/12. Our last example today is writing mixed numbers as improper fractions. We can do that using a method we call the MAD method. So zoom in on that MAD face there. So in this method, MAD stands for the steps we're going to use to make our improper fraction a mixed number into an improper fraction. So the M stands for multiply. So you can go ahead and write that right here. And then the A stands for add, and I'll show you how we do this in a minute. And then D you might think means divide, but it doesn't. It actually means the denominator stays. The denominator is going to stay the same after we do our multiply and add steps. Denominator stays. All right, so here's an example right below that shows that. So the first step to changing 3 2/3 into an improper fraction is going to be to multiply and then add. And we're going to go in this direction. We're going to multiply and then we're going to add. So we multiply 3 times 3 and get 9, and then we add the 2 to our 9 and we get 11, and the denominator stays the same. So we end with 11/3 as an improper fraction that's equivalent to 3 2/3. So the reason we call this the MAD method is if we take those symbols we made, the arrow and the bullet and the addition, and rewrote them down here. Whoops, right down here. If we rotate that on the side, maybe imagine that as an open mouth and tip it over, and it looks kind of like a mad face or a growly face. All right, let's try one last example of that, and then you can have work time. So here we have 12 and 2/3, and we want to do mad. So we're going to show that arrow. We're going to go this direction clockwise. We're going to multiply the denominator times the whole number to tell us how many parts we would have if we cut all 12 of those wholes into thirds. We're going to add the 2/3, which were the fractional part left, and then rewrite it with the same denominator. So 3 times 12 gives me 36, and then I'm going to use my 36 and add the 2, so I get 38 over, and remember the D in MAD stands for denominator stays, so 38/3, and that is the same as 12 and 2/3. This is the improper fraction version of that. All right, let's take a look at your practice today. All right, your homework today is page 8, and I'm going to zoom in. We'll take a look at each section and highlight some important words. So find 2 equivalent fractions for each fraction. And remember, when you're finding equivalent fractions, you can do that using multiplication or division. So you can use either method. So an example would be, maybe I decide I am going to use multiplication first. I'm going to pick a number, any number. Maybe I pick the number 3. I have to multiply the numerator and denominator by the same value to get an equivalent fraction. So I would end up with 9/18. Maybe for my second example, I'm going to use division. So I'm going to divide both my numerator and denominator by 3, because that's the only number that would go into both of them. And I end up with 1/2. So I'd like you to try to use 2 different numbers than I did, but come up with your own equivalent fractions and give at least, or not at least, but do give 2 examples, 2 equivalent fractions for each of the problems. For the next section, we're going to find the missing number that makes the fraction equivalent. So here we have a missing number. So you'll want to think of what's happening, what's the relationship between the 2 numbers you do know, and use that to find the missing number. If you've forgotten how to do that, check example 2 in your notes. Next one goes with example 3. Write each fraction in simplest form. So make sure you go all the way to the simplest form where you can't divide the numerator or denominator by a common factor anymore. That's simplest form. And then here you're going to use that MAD method 6 times to write the mixed number as an improper fraction. And then the last 3, you're taking the improper fraction and writing it as a mixed number. So use the 3 steps just like we did in our notes. All right, good luck. Bye.